Hello. Yeah, I am. The class has started. So can you connect? See, click on the second link first. Go back to the link I sent you. Then click on that second link so you can view the class. After that, if you've clicked it to view the class, go back again and then click that request to join. Please do so I can start. I will have just within 30 minutes. Hello, good
Good
afternoon.
afternoon.
Success to you. How are you doing?
I'm fine.
Good. I hope the network is good at your end, right?
Yeah, yes.
Okay. So we are going to deal with variation, like I sent you in the link. And this is what you are going to see. This is what I'll be using. Are you following, right?
Yeah.
Good. So we have paper there. So without
Yes.
wasting time, let us get to business. Are you with your writing materials there?
Yeah.
Permit me to plug my device. Okay. So we are dealing with variation. We are dealing with variation. Variation. Are you saying it? Are you saying it?
Yes, I'm seeing it.
Okay. So in maths, what is variation? You can put it down. Are you ready?
Yeah.
Variation is a mathematical procedure that shows the relationship between quantities. Variation, a mathematical relationship that shows relationship between quantities. Did you get the definition?
Yeah.
Now, in your examination, nobody is going to ask you normally to define variation in maths. Yeah, you won't be asked that. Are you following right?
Yeah.
What you just need to know here are your types of variation and how you use them to solve problems. So without wasting time, let us move on to types of variation. There are four major types of variation we are going to treat. So list them down. Let us start picking them one after the other. I hope you can hear me clearly, right?
Yeah.
Types of variation. Number one, direct variation. Direct variation. Number two, inverse variation. Inverse variation. Number three, joint variation. Joint variation. Number four, partial variation. Partial variation. These are the four types of variation. And as you're preparing for your exam, you're expected to know those 4 types of variation. Are you with me?
Yeah.
Good. So without wasting time, let us move on to direct variation. Direct variation. Let us discuss direct variation. Direct variation. So what is direct variation? I am going to give you the definition and real life examples. Then we now solve questions on it. Are you ready?
Yeah.
Right. This is the type of variation. This is the type of variation whereby as one quantity increases, the other quantity also increases. Type of variation whereby as one quantity increases, the other quantity also increases. Or as one quantity decreases, the other quantity also decreases. Have you gotten the
Everything is.
definition?
Yeah.
So what do you understand from that definition quickly?
As one quantity increase, the other increase, which means as the values of one increase, the other one is also increasing.
Thank you very much. And what if one of them is decreasing? The other one, what will be happening to it?
It will also decrease.
You are very correct. Now let us think of real life experience where, or real life examples where something like that happens. Think of a vehicle that is traveling from Oka to Onitsha. You don't need to write the example, just pay attention to the example. Are you there?
Yeah.
A vehicle that is traveling from Oka to Onitsha, and a vehicle that is traveling from Oka to Lagos. When you're traveling from Oka to Onitsha and you're traveling from Oka to Lagos, which distance is farther?
From Oka to Lagos.
You are very correct. Now, if a vehicle consumes 20 liters, if a vehicle consumes 20 liters from Oka to Onitsha, what do you think the vehicle will consume from Oka to Lagos? Will the liter of petrol consumed be less than 20 liters? Will it be more than 20 liters? Or will it be equal to 20 liters? If now the vehicle is to move from Oka to Lagos.
It will be more than 20 liters.
Correct. So what can we say of this example? The more petrol will be consumed. Do you understand that, right?
Yeah.
Okay. Now, I would like to take you to chemistry because we'd also meet this in chemistry. There is this law under gas law we call Charles' law. Charles' law. Have you heard of Charles' law before? Have you heard of Charles' law before? Can
Sir?
you hear me? Can you hear
Yes,
me?
I'm hearing you now. The network is
Uh,
disturbing a bit. I'm hearing you now.
I'm sorry about that. I'm sorry about that. Can you hear me now?
Yeah.
There is a law in chemistry we call Charles' law.
Yeah.
It relates volume and temperature. If you're given a gas and the volume of the gas is, let us say, 20 centimeter cube, 20 cubic centimeter. Are you there? Can you hear me? Do you see this?
Yes, I'm saying two only. Two.
I wrote 20. Let me write it again. Volume of a gas is
Oh,
20 centimeter cube. Have you seen it?
yeah, I'm seeing it now.
Good. Let us say the temperature of the gas that has this volume. Let us say the temperature is 5 Kelvin. The temperature is what?
5
5
Kelvin.
Kelvin. Let us say this is the initial volume V1. This is the initial temperature, the temperature of the gas. When the gas was 20 cm cube, the temperature was 5 Kelvin. You know the way gas behaves. Are you following, right?
Yeah.
If I increase the temperature, final temperature, I increase it to, let us say, 20, okay, let's say 10 Kelvin. 10 Kelvin. What do you think will happen to the volume of the gas? Will it reduce or increase?
No, to increase.
It will increase. In fact, since the temperature is doubled, you can see the temperature increased from 5 to 10. Usually the volume will be doubled in that case too, which means when you increase the temperature of a gas, like here, the final volume, V2, in this case, the final volume will be, let's say, 40 cm cube. Can you see the 40 cm cube?
No, I'm not seeing, but I'm hearing what you're saying.
Okay. Can you see the 40 now?
Yes.
You know, these are real life examples of direct variation. As one is increasing, the other one is also increasing. Is that clear?
Yeah.
Let us then go to the maths. Now, in mathematics, if I tell you that x varies directly as y, x varies directly as y, this is how you write it. X varies directly as y, this is how you write it. Can you see it? X varies directly as y. This is how you write it. Have you seen it? Can you see this?
Yeah.
This is telling you this sign or symbol is a symbol of variation. This is a symbol of variation or proportion. Can you hear me? Can you hear me?
Yes, I'm hearing you.
This symbol is symbol of what I said.
Proportion.
Variation or proportion, yeah. So if I tell you that x varies as y, x varies as y, this is how you write it.
Okay.
Is that clear?
Yeah.
So write it under that, right under your definition of direct variation. If x varies as y, if x varies as y or varies directly as y, it is written as, then you write this. If x varies as y or varies directly as y, it is written as, so you write this thing showing on the paper. Have you written it?
Yeah.
Good. Now, you cannot solve anything with this symbol. You can't solve anything with this symbol. So you have to remove it and fix equal to. Are you following, right? Can you hear me?
Yeah.
In maths, you don't solve anything with this sign, this symbol. You don't solve anything with it. So you have to remove it. And for you to remove this sign of variation, you must put equal to and a constant. You must put equal to and a constant in order to remove this symbol. Do you get that? Do you get what I just said? So let us remove
Yes.
this symbol now so that we can be able to solve questions on it. This is how you write it. Watch. It's going to be x you put equal to, and you bring any alphabet you like as a constant. I'm using K. Can you see what I'm writing?
Yeah.
This equal to K has removed this variation sign. Use that constant to now multiply this second variable y. So it's going to be x equal to K times y, which is written as ky. Have you written that?
Yeah.
Good. Now, whenever you are given a question in variation, let's call this equation 1, very important. Let's call it equation 1, very important. Where K, let me define the meaning of K for you. Where K equal to constant of variation. Where K equal to constant of variation or proportion. That's the meaning of K. K is equal to constant of variation or constant of proportion. Are you following, Success?
Yeah.
Good. And you know, the word constant means something that does not change. True or false?
True.
Good. So for any question, once you know the value of this constant, your problem is as good as solved.
No.
This constant is the first thing you obtain whenever you are dealing with variation. But now there's something I want to show you quickly. Once you get the value of this constant, and you bring it back here, let's assume that the constant is 2. You know, this will now become x equal to 2y. True or false?
True.
That x equal to 2y will be called the equation or the formula connecting the variables. The variables are x and y. They are the two original quantities whose relationship you are trying to find. Are you getting me right?
Yeah.
Once you know the value of this k, you fix it into this equation. Let us assume that k is 2. Then x equal to k equal to 2y will become the relationship, the equation, the formula connecting the variables x and y. Because sometimes the examiner will ask you to find that equation connecting them. Are you following, right?
Yeah.
Good. Now, let us do something from this equation 1. The reason I want to do this next thing is because of your chemistry and physics. Because we will meet things like that in chemistry and physics. Are you following?
Yeah.
Let us make K subject of the formula from this equation. Let us make K to stand alone. So how do we do it? Now watch. You know, this is X equal to K times Y. Is that not so?
Yeah.
If I want K to stand alone, I want K to be subject of the formula, I have to remove this Y from here. True or false?
True.
To remove this Y from here, since this is K times Y, to remove this Y, you divide this right-hand side by Y. Are you following?
Yeah.
You'll also divide this left-hand side by Y. So let us do it and see. This will be X over Y is equal to, if I divide ky over y, what will be remaining here?
K.
You are very correct. Let me call this equation 1a because I got it from equation 1. Write that. Have you written it?
Yeah.
Now, this is the reason why I want us to give attention to this equation. We now have x over y equal to k. This k is constant, it does not change. Are you getting me right?
Yes.
In science, whenever anything is equal to a constant, it allows you to write it in a form of initial value equal to final value. For example, because this x over y is equal to constant, it means x over y does not change. Are you getting me right?
Yeah.
The implication of this mathematically, scientifically, is that you can write it as x1 over y1 equal to, again, x over y. But this time around, it will be x2 over y2. Are you getting me right?
Yeah.
This can still be equal to another x over y because x over y is constant. It doesn't change. Are you following?
Yeah.
The only thing now is that you can have it as initial value, final value. Are you getting me?
Yeah.
We meet something like this under gas law in chemistry and in physics. And in fact, in many other science laws, you see something like this. We want to take note. This equation is also an equation for direct variation. When something is equal to constant, it gives you room to write that thing in different stages. It gives you room to write that thing in different what? Stages. This is stage 1 of x over 1. This is stage 2 of x over 1. For example, I just finished a class in GMAS 41 Special Science College. I am still GMAS 41. When I taught the student, I was GMAS 41. The only thing is that I was teaching our students in our school. Are you getting me right?
Yeah.
Right now, I am teaching you as in this private class. Have I changed from GMAS 41?
No.
I'm still GMAS 41. I'm still constant. The only thing now is the condition under which I'm teaching somebody directly. Are you getting me? One person directly. So that is the
Yeah.
idea
I
here.
understand.
If x over y is equal to constant, it does not change. That x over y can be made equal, but with different stages. Are you getting me right?
Yeah.
So that is all about direct variation. Let's call this equation 2. We'll meet this one more in chemistry and in physics. For this math, we make use of equation 1 and 1a often. Is there any question on this explanation?
No.
With this thing, you have gotten a little idea of inverse variation as well too. The only difference between direct variation and inverse variation is that in inverse variation, this will be x, then you put this sign of proportionality of variation, then this will be 1 over y. Are you getting me?
Okay.
Something like this. Let me just write it here. X varies as 1 over y. This one is inverse variation. Don't write it. Don't write it. Don't write it. I'm just showing you so
Okay.
that you have something in mind ahead of inverse variation. Our focus is in direct variation. And now look at something in this direct variation. The variables that are being connected. If this one is numerator, this one will also be numerator. Are you getting me right? If this one
Yeah.
is denominator, this one will also be what? Because they are
Denominator.
directly proportional. Are you getting me right?
Yeah.
But for inverse, you can see inverse, opposite. If this is numerator, this will be what?
Denominator.
Denominator. Because in inverse, if one is increasing, the other one will be doing what? The, you
Decreasing.
know. So I just decided to use this avenue to open your eyes a bit to inverse variation, but we'll still treat it anyway. Let's now focus on our direct variation. We are done explaining the things you need to know. Let us pick some jam questions. Are you ready?
Yeah.
So I have this jam question I'd like us to look at. This is 2011. I am going to dictate the question. I am going to dictate the question. Can you see it?
Yes, I'm
If
seeing.
x, if x varies directly as square root of y, if x varies directly as square root of y, and x equal to 81, and x equal to 81 when y equal to 9. X equal to 81 when y equal to 9, comma. Find x. Find x when y equal to, I hope you can see it there, right?
Yeah. When y equal
Find
to.
x when y equal to one whole number 7/9. One whole number 7/9. Now we have options there, but don't copy the options. They are not absolutely necessary. You are being
Okay.
trained to believe in yourself that once you solve, if the correct option is there, you should get that answer. So we are going to solve and then come back to the option. Do not copy the options. Have you copied the question?
Yeah.
Okay, now let us solve it. You have the question now. We are told
Yeah.
that x varies directly as square root of y. X varies directly as square root of y, which means that y is in square root form. Is that not so?
Yeah.
Mathematically, this is question 1, Q1. Of course, this is JAM class we are dealing with. This is JAM. JAM 2011.
Please, I'm coming.
Okay, no problem. Are you good?
Yeah, I'm back.
All right. If x varies directly as square root of y, mathematically we write it as, can you look at what I'm writing? X
Yes. I'm not.
varies. Can you see it?
No.
Okay, hold on. It could be network. X, can you see it now?
Not yet. Okay. Yes, I'm seeing it now.
X varies directly as the square root of y. So that y will bear square root like this. Do you understand this?
Yeah.
That's the meaning of that statement in the question. If x varies directly as square root of y. Now, you know you cannot solve anything in mathematics with this symbol, this variation sign, this proportionality sign. You can't solve anything with it. Can you see it?
Yeah.
So we have to remove it and introduce a constant. X will now be equal to, I'm using k as my constant. That k will multiply the other variable, which is square root of y. So it's going to be k times square root of y. Can you see it?
Yeah.
So this is the first and most important thing. Now, next is for you to get the value of k, the constant. You must know the value of this k because it does not change. It's a constant. You have to calculate it. Are you getting me right? Do you understand that?
Yeah.
So let us find the value of this k. Let's calculate it first. And to calculate it, you have to go back to your question. Go back to your question, please. You are told from the question that x equal to 81 when y equal to 9. True or false?
True.
So do you see? They gave us the value of this x and they gave us the value of this y. So we'll use this value of x and value of y. These are the initial values. Are you getting me right?
Yeah.
We'll use that value of x and value of y to calculate k. So let us do substitution now. Let us replace those values. From the question, x is equal to 81 first, and that time y is equal to 9. So you come to this equation and substitute. In place of x, I will fix 81. Are you ready?
Yeah.
So this will be 81 equal to what I am doing. Let me be done solving it, then you can copy. Are you following, right?
Okay.
Now your K, you don't know the value, you maintain it, times square root of, what is the value of Y given in the question under this condition?
9.
Fix 9 there. So your 81 will now be equal to, square root of 9 is what?
3.
Correct. 3 times K will give you what? 3K. Do you understand this?
Yeah.
To get the value of K, what do we do from here? You divide both sides. You divide both sides by the number multiplying K. Is that not so? If you divide it by K, what will be left? So if you divide it by 3, if you divide it by 3, what will be left?
K.
So you write K equal to, come to this 81 divided by 3. 81 divided by 3, do you know what you're going to get? Now, your excellent knowledge of multiplication is very, very important. I have continued singing this out to students. 81 over 3, do you know what you're going to get? Let us do it and see.
27.
You are correct. So I don't need to talk much again. With your excellent knowledge of multiplication, you can work on this. 3 can divide 8, can go into 8 2 times, remainder 2. Attach the 2 to this 1, you get 21. 3 can divide 21 7 times exactly. So K is equal to 7. We have gotten the constant. Are you following, right?
Yeah.
Now pay attention to what I'm about to say now. This question given to us, we were not asked to find the relationship, the equation, the formula connecting the variables x and y. Did the question ask us to find it?
No.
But I want us to find it. I want us to get it, because in some questions, an examiner might just tell you, find the relationship between the variables. So you should know how to get the relationship. Am I communicating?
Yeah.
Do you understand that?
Yes.
So let us get the relationship, please. Let me write it. The equation connecting the variable, the equation or relationship or formula connecting the variables, connecting the variables, connecting the variables is, I'm doing this thing in case your examiner asks you to find equation connecting the variables. There are some questions they will just ask you that thing, find the relationship between the variables, or find the formula connecting the variables, find the equation connecting the variables. What you have to do is get the value of your constant. Are you getting me?
Yeah.
Can you see what I'm doing clearly, right? So get the value of the constant. Then go back to this equation where you remove this proportionality sign and introduce equal to and a constant. Go back to it. Copy everything you have there, but replace the value of K that you have gotten. What is the value of K that we have calculated?
27.
So the equation, the relationship, the formula connecting the variables will now be X equal to, in place of K, you fix 27, then root Y. This is the relationship connecting. And this is the formula you will use to solve anything you want to solve on this particular question now. This is the formula you would use. Please copy what you have so far before we proceed to the main thing we're asked to solve. Copy what you have done so far.
I'm
Are you
done.
finished? Okay. So you know how to get relationship connecting variables now. All you just have to do, get the constant of proportionality, get the value, then go back to the original equation, and then fix that value of the constant. Are you following? Now go back to the question. What did they say we should now find, and under which condition? Please read out the main problem we are solving here. Because what we have done here is not the main problem yet, but it's part of solving the main problem.
Find x when y equals to 1 whole number 7/9.
Correct. So we proceed. We are to find x. I'll now write x I do not know. Under that condition, y is equal to 1 whole number 7/9. Are you saying it?
Yeah.
So all you have to do, carry this value of y, which is 1 whole number 7/9. Go to this relationship. Remember, I told you any other thing you solve for this question, even if they give you 5 questions under this thing, you are going to use this equation to solve all of them. That is how powerful this relationship is. Are you getting me right?
Yeah.
So go back to this equation now. You are looking for x. You don't know x. So I'm going to write x. Are you seeing this?
Yeah.
It's going to be x equal to, I'm following this relationship, this formula, this equation connecting the variables now, equal to 27 times square root of 1 whole number 7/9. You know that y is 1 whole number 7/9. Is that not so?
Yeah.
Good. Now, anytime you have mixed fraction like this, you know that the rule is you convert it to improper fraction. True or false?
True.
Now, I'm going to throw the question at you. If you convert 1 whole number 7/9 to improper fraction, please work it out. What would you get?
16/9.
You are very correct. So that 1 whole number 7/9 will change to 16/9. Let me complete it here. So we have x to be equal to 27 times square root of 16/9. Are you following?
Yeah.
Good. Faith David, I saw your message, but of course I can't attend to you right now. But you're welcome to connect to this. You can learn 1 or 2 things anyway. I'm personally on with someone now. Now, in success, if you have square root of 16/9, square roots distribute over division. It can distribute over division. So you have to split this square root to 16 and split it to 9. So it's going to be square root of 16 all over square root of 9. Are you following, right? Can you see this? Can you hear me? Can you hear me?
Yes, I know. Yeah.
Square root of 9. Can you hear me?
Yes, I already know.
So I 16 over this square root is affecting both of them. Are you following? For division and multiplication, this thing is division, 16 divided by 9. These square roots will be distributed to the numerator and denominator. Are you following, right?
Yeah.
If it is multiplication, 16 times 9, for example, the square root will still affect each of them separately. That's something you should know. So square root of 16, what will you get? Success?
4.
You are correct. Square root of 9, what would you get?
3.
So that square root of 16/9 will actually now change to 4/3. Do you agree?
Yeah.
So this will be x equal to 27 times 4 over 3. Now you can divide before multiplying. Anytime you have division and multiplication, it is advisable you check for division first before you go do multiplication. That is what Bodmer said. And apart from that, division will reduce the number for you. Are you getting me right? To be easier for you to now multiply. So can this 3 in the denominator divide anything in the numerator? You have 27 in the numerator, you have 4 in the numerator. Which one will 3 divide?
27.
You are very correct. 3 can divide 3 to give you 1. 3 can divide 27 to give you what?
9.
Good. So x is now equal to what times what?
9 times 4.
And 9 times 4 will give you what? It's the same as 4 times 9. 9 times 4 is the same as 4 times
36.
You are correct. So you have to continuously work on your multiplication. Are you following right?
Yeah.
Even in JAMB, that knowledge of multiplication is the stronghold to be fast in your calculation. So the value of x when y is one whole number 7 over 9. The value of x under that condition is what? 36. Do you get it?
Yeah.
Please copy. When you're done copying, I will now display the option. Let's see whether we were able to get the options that JAM provided. Whether the question is anything difficult. Of course, it's 1 plus 1. That's the truth. It's 1 plus 1.
I'm done.
Good. Now look at the options. I hope you saw the question. You are still aware of the question we solved. JAM 2011. So look at the options. Option A, 20 whole number, 1 over 4. Option B, 27. Option C, 2 whole number, 1 over 4. Option D is what?
36.
So did we get the answer?
Yeah.
Good. And that is that about direct variation. There is nothing there in direct variation. It's very simple. Quickly, I want to show you if in real life this thing is actually true. Remember, I defined direct variation before we started doing all this analysis. Is that not so?
Yeah.
And we say if one is increasing, the other one will also be what? Increasing. Now take a look. In the first case, the value of x was 81, true or false?
True.
And the value of y that time was what?
9.
Good. Now, when y, something happened to y here is one whole number, 7 over 9. Is that not so?
Yeah.
And when we did the conversion, one whole number, 7 over 9, gave us 16 over 9. 16 over 9 should be there about 1 point something. Yeah. I think 1.6. 1.6 something. Are you following right?
Yeah.
Good. Which means the value of y in the second condition is 1.6 something. Yeah, let's say 1.6. Success, I want to ask you this question. Y here was 9. In the second condition, y now is 1.6. Did y increase or decrease? Did y increase or decrease?
Decrease.
It decreased. Is that not so?
Yeah.
So for direct variation, what do you expect of x? Will x increase or it will decrease?
Decrease.
Now let us find out whether x decreased after we solved. For the first case, the value of x was what?
81.
Finally, the value of x we calculated when y reduced to 1.6 something. The value of x was what?
36.
From 81 to 36. Did it also decrease or not?
It decreased.
So you see that this thing is real life situation. Are you getting me right?
Yeah.
and that is the principle of direct variation. And now I want to quickly tell you something about this direct variation before we close. Then I will drop a link for you to take. I have introduced this. So the knowledge of what I explained there would also even guide you in inverse variation, because I will send you a link where you will take the lesson on inverse variation. Are you getting me right?
Yeah.
You see this equation? We could have used it to solve this particular question and get the same answer. Because if you look at the question we solved, remember this equation: x1 over y1 equal to x2 over y2. Are you seeing it?
Yeah.
The only thing is, if you use this equation directly, you won't get the value of k. You won't get the constant. Are you following?
Yeah.
But you get the answer of the final value of x they want you to get. You get it directly. Like in physics, there are some cases we meet this thing. There are some questions like in simple harmonic motion. We are going to apply this, where you relate the period of a simple pendulum to the length of that simple pendulum. We meet something like that, and you won't be going through this thing I did here for direct variation. You don't do that. You can just use this equation. Like in this case now, what we have to do is simple. The first value of x given to us was what? In the question, the
81.
first value of x, 81. Is that not so?
Yeah.
Then it's going to be 81 all over. The only thing is that from the question, remember that y will bear square root, true or false?
True.
Good. So that if I want to use this equation to solve this particular question, this is the form it will take. Let me show you. It will be x1 over square root of y1. Remember that y was said to have square roots in the question. Is that not so?
Yeah.
Equal to the second value of x, which we are looking for, all over square root of y2. This is what the formula will be. And I would like you to use this formula to also prove that, yes, we will get that final result. X1 is 81. You fix 81 over square root of y1 is 9. Is that not so?
True.
Equal to x2, the final value of x we don't know. That's what we are asked to find here. Are you getting me right?
Yeah.
But then y is one whole number, 7 over 9. You did a conversion that time. You remember you got 16 over 9. True or false?
True.
So the second value of y, which is y2, will now be square root of 16 over 9. And you can solve this. You get 3 over 4. Oh, no, you get 4 over 3. Are you following, right?
Yeah.
Do your cross multiplication. Make x2 subject to the formula. Solve this thing. And I'd like you to snap and send me what you got. Are you following? You send it to me on WhatsApp. If you solve it, you're going to get 36. Solve it now, but just copy this thing. You could have used this direct approach to solve it. So copy it down and then finish it up. I am hoping that you still get that 36 as the value of x2.
Okay.
Have you copied it?
I'm almost done.
Okay. You have to solve it, then you can send whatever you get to me anytime between now and 8 p.m.
Okay.
I want us to confirm whether through that approach, if we still get this result. Are you following, right?
Yeah.
Finally, let me show you another thing about direct variation, because there are some type of questions that might be given to you. It is best to use that approach, like under gas law in chemistry. Direct proportion or direct variation follows this format also. Are you there?
Yeah.
X1 is equal to y1 value. But remember that our y1 here is square root, true or false?
True.
So x1 should correspond to square root of y1. Whatever mathematical function they give to you here, you use it. If this thing were to be that x varied directly at square of y as square, whenever you are dealing with square, if it were to be square of y, you know that this thing will be y raised to power 2. Is that not for square?
Yeah.
So you should be aware of all these things. Sometimes they will tell you that something varies as a cube of another thing. When you are talking of cube, that another thing will be raised to power 3, true or false?
True.
But if you don't have all those special functions, you can relax and then solve. If I had told you that x varies directly as y, I wouldn't be needing all these square roots of a thing. I hope you know that.
Yeah.
Now, I want to show you the final approach one could use in direct variation. Very fast and simple. Nothing is there. It's 1 plus 1. X1 will produce the value of Y1 here. Of course, with the square root, because in the question we are told that Y has square roots. I hope you are there, right?
Yeah.
So what will be the value of X2 corresponding to a given value of Y2? What will be the value? So all you now have to do is to fix their values and cross multiply. Do you understand me?
Not actually. Like cross multiply how?
Now don't worry. Watch. X1 should give a corresponding value of square root of Y1. True or false?
True.
And then X2 is also expected to give a corresponding value of square root of Y2 because they are directly proportional or they vary directly to each other. Are
Okay.
you there?
Yeah.
Are you there?
Yes.
So in this question we just solved, you could have just done the first value of X given to us, which we're going to call X1. The first value was what?
81.
So we could just have done 81 equal to square root of the first value of Y was what?
9.
9. So 81 would be directly proportional or very directly as square root of 9. Are you there? Are you seeing this?
Yes.
Therefore, what will be the value of X? You don't know, which is the final value of X, X2. What will be the value of X when you were given the second value of Y? Remember the second value of Y, one whole number 7/9. Is that not so?
Yeah.
Which we converted to 16/9. Do you still remember?
Yeah.
Good. Are you saying this?
Yes.
So from here, you cross multiply. You do what?
Cross multiply. Okay.
X times square root of 9 is already 3. I hope you know that, right?
Yeah.
You get 3x equal to 81 times square root of 16 give us 4 over square root of 9 give us 3. Is that not so?
Yeah.
So simplify this part and then make x subject to the formula. Get the value of x. You should still get 36. So you see this arrangement. The first value of this will give you the first value of this. Therefore, this one will now give you what? That is the idea here. That is the idea here. So anytime
Okay.
in real life, something follows direct variation principle, a direct proportion principle, you can arrange it this way. I will finally tell you something that will guide you or to always remember this. However, look at this guy, copy it. I also want you to verify that you will get the same answer if you use this approach. 81 equal to square root of 9.
I'm
Therefore,
not hearing.
x will now, I'm sorry, just stay calm and then it will show up. Are you seeing it now?
Yes, I'm seeing it.
You're seeing it now, right? So copy it.
Okay.
Be fast because our time is up now. It's meant to be 1 hour
Okay.
class at least. This is 54 minutes now.
I'm done.
Good. So simplify this and then solve for x. Remember, you are still doing this. So these are the two things you will submit. I want to see the end of it if you get the same results, just for you to be assured. Because the truth of the matter is, in real exam situation, if they give you direct variation question, you really don't need to go through all these processes, except if the examiner requires that you get the value of the constant. Are you getting me right?
Yeah.
or the examiner say you should find the variable, the equation connecting the variables, or the formula connecting the variables, or the relationship between the variables. If they ask that, you must go through this format. Are you getting me right? So as to get it, yeah.
Yeah.
But these other approaches, this one, they don't respect that constant. You have no business with it. They just give you the direct answer of what you are looking for.
Okay.
Now, success, finally, I have this question for you. Imagine I tell you that one orange is sold for 5 naira. One orange is sold for 5 naira. You know, when it comes to buying and selling, generally, it follows direct variation principle. When you're talking about buying something and the cost of that thing, it follows direct variation principle. Are you aware of that?
Yeah.
Because the higher the quantity of something you buy, normally the higher the cost. True or false?
True.
If I tell you that one orange is sold for 5 naira, I can tell you I can ask you how many oranges will 15 naira buy? One orange is sold for 5 naira. 15 naira will buy how many oranges? What will be your answer?
3.
Do you know that that thing is direct variation?
Yeah.
Let me show you how you got that 3. Can you see my writing material here?
Yeah.
My supposed board. One orange is sold for 5 naira. So one orange equal to 5 naira. Can you see it?
Yeah.
How many oranges? You don't know. So you can call it any alphabet X. How many oranges will 15 naira buy? This is the way you arrange it. Direct variation. This one gives you this. So what you are looking for now, what you are looking for, you have this 15 naira to. So from here, you cross multiply. Are you getting me right?
Yeah.
If you cross multiply, you're going to have x times 5. False.
True.
Which will give you 5x equal to 1 orange times 5. You know, this naira will cancel because the amount of money they are complete here. I told you that, okay, one orange goes for 5 naira. So how many oranges will 15 naira buy? So this naira will cancel out. Are you getting me right?
Yeah.
You know, you are left with looking for orange. You are left with looking for what? Orange.
Orange.
You know, in physics, there's something we call units and quantities and their units. Anyway, let's move on straight. 1 times 15 will give you 15. True or false?
True.
So after cross multiplication, this is what you have. What do you do to get your x?
Divide both sides by 5.
Good. And if you divide both sides by 5, x will now give you what?
3.
That is how you know that 15 naira will buy 3 oranges. Now, it's just that most times we really don't, some of us don't understand how this thing applies to math. Some people will be asking every time you're looking for X, what are you using the X to do? You use the X to do something. This is the mathematics. This is how the brain actually found out that this thing is going to buy 3 oranges. In the same way, I could have told you, okay, if one orange goes for 5 naira, 3 oranges will be sold for how much you don't know. In that case here, you fix 3 oranges. Are you getting me right?
Yeah.
Equal to you don't know how much we buy the 3 oranges. You cross multiply and then solve for the unknown. So all these things are principles of direct variation. They are principles of what? Direct
Direct.
variation. This law in chemistry we call Charles' law. Charles' law actually makes use of this principle because Charles' law is direct variation law. In chemistry, I am going to remind you of this when we treat Charles' law under gas. Is that okay?
Yeah.
Any question?
Not yet.
Not yet. There will be none. We've broken down everything you need in direct variation. There's nothing in it again. I'll
Okay.
send you I'll send you some links tonight that you take on variation, because you have to take inverse variation with what I've done here in direct variation. If you take the video lesson, pre-recorded video lesson on inverse variation, it will be super cool. Are you getting me right? So let's so this is how we come to the end of today's maths class. Did you learn anything from it? Did you enjoy the class?
Yeah.
Good. So with these, you can finish the other two variations, and then it will now be left with joint variation and partial variation, which I will still teach you in live class.
Okay.
All right, bye. I have to
Right.
attend to Unizik. I have tutorials shortly after now with 100 level students, physical class. So I'm heading to Unizik quickly.
Okay. Okay. All right.
Bye. Regards to your household. Remember to
Okay.
submit the assignment I gave you, that verification between now and 8 p.m., okay?
Okay.
Okay, bye.
All right.